Hello guys, and welcome again to my YouTube channel. Don't forget to subscribe, like this video and share it to your friends. Okay, today we're going to be taking differentiation part 7. And I'm going to be teaching you quotient rule. So we're going to derive that first. And then in our next video we can solve problems on it. So the quotient rule in differentiation is a law that covers two variables dividing each other in a function. So let's say we have a function y is equals to u all over v. Then we know that solving it from first principle, like I said, is going to give us dy plus y is equals to u plus dy all over v plus dy. So we are trying to derive our quotient rule. So let me give you what we're supposed to be deriving. Our quotient rule, if y is equals to u all over v, then our quotient rule is going to give us dy dx equals to v du all over dx minus u dv all over dx all over v squared. That's what we're supposed to be getting. So we're going to solve this now from first principle to prove that this, when this is equal to this is equal to this. So in this case, the y, there's a mistake there, u plus du, not dy, all over v plus dv. So in this case, we're going to start the solving. First of all, we know that y is equals to u all over v. So u all over v plus dy is equals to u plus du all over v plus dv. So taking this over to this side will be we end up subtracting it. We'll have dy is equals to u plus du all over v plus dv minus u all over v. In that case, subtracting it, we're going to get u plus du times v plus dv times u all over v plus dv times v. So u plus du times v, that will be v bracket u plus du minus, this minus comes down, u times v plus dv all over v, okay, v plus dv. So expanding it, what are we going to be having? uv plus v du minus uv minus u dv. That's the case because the minus is going to be minusing, changing this plus to the bracket into minus, and we're going to be having v times v, that's v squared, plus v times dv, that's v dv. Okay, so what's our next course of action? Dy is equals to uv minus uv, and if we bring them to the same place, uv minus uv is just going to give us 0, so they're going to cancel each other. We're going to have v du minus u dv all over v squared plus v dv. So dividing through by dx, we're going to be having dy dx is equals to v du over dx minus u dv over dx. In this case, I just want to divide only the numerator by dx. It doesn't really matter whether I divide it by the top or the bottom. It all gives us the same result. So it's going to be easier to use the numerator first to divide it by the dx, it's going to be easier than to use or to divide the entire thing by that dx. So in this case, we're going to be having dy dx is equals to v du all over dx minus u dv all over dx all over v squared plus v du. Now we're going to take limit of dx, the limit of dv in the function where dv tends to 0, where v dv tends to 0. So if dy dx is equals to v du all over dx, sorry, that's v du all over dx minus u dv all over dx all over v squared plus v dv, limiting v dv where it tends to 0, we're going to be having dy dx is equals to v du all over dx minus u dv all over dx all over v squared. That's our answer. So now we have successfully proven that if y is equals to u all over v and dy dx is equals to v all over v du dx minus u dv dx all over vx, that's our final answer. So don't forget to subscribe to my channel. I'll be posting more of these frequently.